Hey guys, Hydrid here. Today I'm going to show you how to find the eigenvector, eigenvalue, and figure out the basis of an eigenspace's dimensions using SageMath. So let's get into it. First, we're going to need to set up the matrix for the problem. I prefer using this method of setting up matrices, but I believe there are two other methods or one other, but this is just the easiest. So you get the amount of rows and the amount of columns, and then you just type it in. And then you could verify that's the right matrix. As you can see, it is the same. And finding the eigenvalues and eigenvectors are very simple. All you need to do, I prefer to do show. You could also do print. Show A dot eigenvalues and A dot eigenvectors right. And as you can see, you get the two eigenvalues and the two eigenvectors. But what about the basis of the dimension? That third question of the problem, you need to look at these. There's one vector per eigenvalue, which means none of the eigenspaces have dimension 2 or larger. I know I just explained that poorly, but you'll see it in a future problem. So we hit evaluate after typing it in, and then there we go. We can see the eigenvalues and the eigenvectors. And again, we see that the eigenspaces do not have a dimension 2 or higher. Now let's go to a third one. This one is a 3 by 3 matrix, so we're going to change it and just type it in. And then there we go. We see our 3 eigenvalues and each corresponding eigenvector to the eigenvalue. And again, we see that the eigenspaces do not have a dimension 2 or higher. And then for the next problem, we just type in the matrix and hit evaluate. So we see our 3 eigenvalues, but you notice there's two ones. And as I was talking about earlier, for this eigenvalue, there's technically 2 eigenvectors. And thus, we can put down exactly one of the eigenspaces has dimension 2 or higher, which that is the eigenvalue 1, and the basis is this. So we type in the matrix, hit evaluate, and we can see the eigenvalues. And again, we see that there's a duplicate eigenvalue. So when you look at the eigenvectors, you can see 2 has 2 separate eigenvectors. And thus, one of the eigenspaces has dimension 2 or larger, which that eigenvalue being 2, and has a basis of these 2 vectors. The final problem, this is a bit larger. It should be fairly annoying to do by hand, I believe. And then once you got that typed in, we see the 4 eigenvalues. And we see that each eigenvalue has one corresponding eigenvector. And thus, none of the eigenspaces have dimension 2 or larger. So that's how you simply find eigenvalues, eigenvectors, and the basis for each eigenspace. Thank you for watching.